the crew of Artemis II, now bound for the moon. Humanity's next great voyage begins.
Hello, Dr. Alison McGraw with her Cosmic Orbit. We are on site for the Artemis II mission, and we have a special guest joining us today.
Hi, I'm Dr. Jennifer Heldmann from NASA Ames Research Center and just a planetary scientist at NASA.
Wonderful. Thank you so much for taking the time. We wanted to talk a little bit about, as her Cosmic Orbit focuses on the experience and in the Artemis era as a woman compared to the Apollo era, how your specific role, how you feel maybe in comparison, contrast where we were, where we are today for women specifically.
Yeah, no, it's been great. We have a wonderful team of incredibly qualified people who are on our science team. I think it is majority women on the science team. But we were just talking about that the other day, and we were like, we don't really even notice. And I think that's great because that's the point we've gotten to, where it's just you have the people who are qualified and ready to do the job in those positions. So it's been super.
We're lucky that in planetary science and astronomy, it's almost reached a 50-50 balance.
Yeah,
Sounds like it might be more than 50-50 for Artemis.
It's been really great. And I actually had a moment with one of my daughters, and I was trying to explain to her, we're sending people back to the moon and with Artemis, and like the first girl is gonna walk on the moon, and like she just looked at me and was like, so? And I was like, and she was like, well, people have already walked on the moon, so obviously girls have already gone to the moon. And I was like, do I correct her? Or do I rejoice that the world she's growing up in, she doesn't even see those boundaries? Like she doesn't
not even a
consciousness. Exactly.
Limitless.
So I didn't say anything because I was like stopped in my tracks, but I think that's a good sign for, people just doing what they want to do, no matter what.
That the current era of young girls, females in space, don't necessarily even have a capping boundary at ever.
Right.
What
exactly.
a world to live in.
Yes, so
yes.
That's great.
You mentioned Reed observing meteors. Can you speak to that? Were you referring to comets or impact flashes or something else?
Yeah, there was a little bit of giddiness. We have seen 3 impact flashes so far. I saw 2, and Jeremy has seen 1. Undoubtedly, Jeremy saw 2, so that's 4 total. Undoubtedly, quick impact flashes. It was not sun glint off of particulate from the thrusters or the purge tanks. It was definitely impact flashes on the moon. And Jeremy just saw another one. Go ahead with your next question.
Amazing news. I literally just looked over at the SIR and they were jumping up and down literally. If you could describe where on the moon you saw them, please.
So they've all been either on or a bit south of the equator and on the Earth side of the moon. Stand by. All right, so Jeremy has seen them kind of on and south of the equator, kind of spread across the moon, and mine were both south of the equator and just a little bit left of center of the moon.
Incredible news, Reed, and reminder, we have citizen scientists here on Earth looking for impact flashes, so hearing you saw them on the near side means that people saw them too.
Given the extent of your science roles within the entire Artemis program, looking ahead to Artemis IV and thinking of the directives or science themes, how might the number of impact flashes redirect, or will it at all impact the science themes moving forward?
Oh, that's a great question, because I was the impact science theme lead. And so I was like, we have to look for impact flashes. There were like bets going on, like, are we going to see any? We're probably not going to see any. Like, we have to look. And then we saw a bunch. And so it's amazing. So I think I spent all day today going through the crew audio descriptions, when they detected flashes, their notes of where they saw the flashes, their descriptions, and correlating all those data sets. I think we're just at the tip of the iceberg because it is important. Because it's telling us, the moon is a dynamic place. Like, there were these meteoroids impacting the lunar surface during Artemis II, during their flyby. They saw them. New craters are being formed on the lunar surface, like right now. And so it's a testament to the, dynamic nature of the moon. So I think we're still, wrapping our brains around, like, what does this mean? And there's still a lot of analysis to go, right? We want to look at the impactor flux and the, size frequency of those impactors. And I think it's also showing the utility of having the humans, like in the Artemis II, in that trajectory, being able to look down, because they're able to see maybe smaller impacts that we couldn't observe from Earth. So we're getting that tail end of the size distribution. Like, what's the smaller stuff that you could see? Because these are not, giant thousands of kilometer size impacts. So we're still, it's day one. So we're still getting data down and still trying to see what that means. But we have to look at it in terms of building infrastructure and building a moon base eventually.
Looking forward to that.
We just realized that we have Earth out window 1 and Moon out window 2. And Earth out window 4 and Moon out window 3. And it gives you the best idea of scale we have had yet. The Moon is about 3 to 4 times the size of the Earth, and it is almost full, and the Earth is just a small crescent out there. It's magnificent. I got a picture of it with the wide lens. Such a majestic view out here.
Amaze, amaze, amaze. Thank you, Reed.
The closer proximity allowed a kind of an extreme end member to be observed for impacts on the moon. Can the planetary science community look forward to any data product that might have angles, trajectory similar to parallax, since the Orion was moving over? Will we actually be able to get any directional vectors?
Yeah, we should be able to. All of the data that we've collected will be publicly available. It will all be released. So we are thrilled about that and hoping that the lunar science community and the world at large will take this data and just run with it. So nailing down the times right now of when those impacts occurred and when the crew reported those impacts. And of course, we can match that with trajectory information. So all of that correlation still has to happen.
Where data and modelers in our community come together. I specifically think of NASA Johnson's Fireball camera system as well. So perhaps there could be models that are extracted and used for lunar science as well here.
Absolutely, and that's why we tapped into the citizen science community ahead of time too, to get those types of programs on board and let them know, hey, you can observe from the ground, provide us valuable scientific data to correlate with what we see with Artemis II. So yes, and there are pipelines already that exist for doing this type of analysis, and so absolutely that is the plan, is to have the community be involved and contribute wherever anyone possibly can. Because we don't need to recreate the wheel. We should use what we have and use the talent that's out there.
Exactly. We've already spent the money on the supercomputer and the models.
Figured it out.
And so recycle, reuse, reduce.
Right, exactly.
Yes. And if we have time for one more discussion for the strategies for sampling in the PSRs, the permanently shadowed regions, define your acronym, and curating an ice rock mixture, looking ahead to Artemis IV.
Yes. So that's near and dear to my heart because I studied the volatile, so I'm very, very excited about this. So hopefully we'll be able to sample, ices from the South Polar region. It can be in the PSRs, it could be out of the PSRs, because we've learned from modeling, thermal modeling, that even if you're in a sunlit region that gets some sunlight, each month, you can actually just go down, a few centimeters, maybe tens of centimeters, and you're still at those cold temperatures that you see in PSRs. So even if you don't get into the shadow region, you can still reach where it's cold enough to trap that ice. So that's very cool. And then hopefully we can sample it. It would be great to sample from the surface. It would be great to sample from various different depths. You have to have a sealed container, so that you trap those volatiles so you don't have those escape. Both for science reasons, we want to keep the volatiles in there to see what was there, for crew safety reasons, all sorts of reasons. Probably the first Artemis landed missions most likely won't have a freezer on board, so those samples come back at ambient temperature. Some of that will volatilize, but we can still get the headspace gases out, and so you can see what was in there. Then we can deep freeze them, once we get them back to the ground, and are developing techniques right here at NASA Johnson for curation to extract what was in there and figure out what volatile species, what ices might be at the South Pole of the Moon.
Or mixtures.
Yes.
Different fate. Well,
definitely. My money would be on mixtures. We saw that from the L-Cross impactor in Cabeus crater, which excavated into a permanently shadowed region, kicked up a plume of dust debris. We flew through that plume with our spacecraft, with all the instrumentation, and we just saw a whole host of different types of ices. That was another one of those mind-blowing moments where we didn't know what we would see, and we just saw a lot. So it makes it even more exciting to go and get samples of that ice and regolith mixture, bring it back into the labs here, and see what's there, what's the distribution, how is it intermixed with the regolith, and just start trying to tackle those science questions of, how old is that ice? When was it delivered? What's happened to it since it's been on the moon? So there's a lot of science that can be done.
And thinking of the astronaut safety combined with picking up samples, not going all the way into the shadow seems critical for not completely freezing. So if you're able to sample just 10 centimeters near the PSR and still have the mixture of ice.
Yeah, you can still get that mixture of ice. And then the suits will be rated to go into shadow for X amount of time. So you can bring a light so you can see what you're doing in there. So we'll see how the first landed missions depends on where you land and what the topography is and where those shadows are. But at least the takeaway is, the South Polar region, there are lots of places, regardless of where we land, where we can do volatiles and ice studies. So that's really cool, and I'm very excited for that.